Here we have triangle ABC, similar to triangle XYZ. And remember, the way this is written is lining up all those corresponding parts, like angle A and angle X would be congruent. Segment AB and segment XY would be proportional. Now, the other thing that we would also know, if I have altitude BD, remember an altitude is going from a vertex perpendicular to the opposite side. Well, the corresponding altitude, well, B corresponds to Y, so the corresponding altitude would come from Y and be perpendicular to the opposite side. Let's say if that's YW, those corresponding altitudes, they would also be proportional. So we could set up a proportion, say segment AB over XY would have the same ratio as BD over YW. So when we're looking at these similar triangles, we know that corresponding altitudes are going to have the same ratio as these corresponding sides. We can set up proportions to find those. The same would also be true if we talk about medians. Remember, a median goes from a vertex, like X, to the midpoint of the opposite side. That side's being cut into two congruent pieces. That would make this segment a median. All right, so if that is point N, our corresponding median would go from A to the midpoint of this side, say if that's point M. So we would have segment AM and segment XN would be corresponding medians, and again, they would be proportional to one another. Likewise for angle bisectors. Now an angle bisector, again, if we're talking about corresponding angle bisectors, if I go from Z and it cuts this angle into two congruent parts, well, it's going to intersect this side over here somewhere, so that this segment, remember this is an angle bisector, so this is being cut into two congruent parts. So then we have this segment ZR, and then my corresponding angle bisector would come from C, coming across here. Again, it's cutting this into two congruent parts. And so then I have my corresponding angle bisector over here would be whatever that might be, segment CT. Those would be corresponding angle bisectors, and again, they would have the same ratio. So if I was looking for my altitude BD, I could say, well, I know segment AB and segment XY would have the same ratio as BD and YW. Or I could be talking about the medians and say, again, segment AB and XY would have the same ratio as we had our median AM and XN. Or if we're talking about those angle bisectors, again, our ratio of AB to XY would have the same ratio as CT to ZR. Here we have one triangle, and in this triangle we have the angle bisector. And we've talked about before that this angle bisector, as it cuts across here, cuts this side. It does not cut it in half. It's cutting the angle in half, but that doesn't mean it's cutting this side in half. That's only in special cases. That's when we're talking about an isosceles triangle and we're bisecting the vertex angle. However, it does cut it proportionally. And what we would have is whatever sides make the angle, the ratio between those two sides would be the same then as the ratio that this side is being cut. And again, X would kind of correspond here with A, Y would correspond with B, because those are the sides that they're on. And remember, there's more than one way that we can write these ratios. I could, again, say A over X would have the same ratio as B over Y. But all we're saying then is that this angle bisector cuts this third side with the same ratio as the two sides making the angle. What that means is that if I'm given a triangle like we are here, where we have an angle bisector, and I'm looking for this segment, segment X is our missing piece, and I'm given my sides 17 and 20, and then this portion of the third side is 12, I could set up a proportion to find X. Again, there's lots of ways to set this up. I could say 17 over 20 17 over 20 would have the same ratio as x over 12. Now we cross multiply and solve, so that would give us 20 times x is equal to 17 times 12. I'm going to divide both sides by 20. This is where we use our handy dandy calculator. So I'm going to have 17 times 12, and then that's 204, and I'm going to then divide that by 20, and we find that x is 10.2.